Welcome, students and friends. In this video, I'm going to talk about the center of mass of a two-dimensional system. So the concepts of one-dimensional system get passed through the two-dimensional system as follows. In the case of a one-dimensional system, we only have x's, x1, x2, all the way to xn. But with the two-dimensional, that means we're going to have an x and a y. So that means that we have x, 1, y1, x2, y2, all the way to xn, yn. So basically, a two-dimensional system is an extension of the one-dimensional system. So the moment, so remember, the moment about the origin was based on x, but now we're going to have two moments, one for the x and one for the y. So I'm going to call it x naught and m y naught. So each little moment about the origin for each x and y is going to be equal to m1 x1 plus m n xn. Similarly, for y is going to be equal to m1 y1 plus m n yn. The only remember, for one-dimensional system we have the total mass. This one it doesn't matter, so it's still going to be the same. So m is equal to m1 plus all the way to mn. So it's the total sum of that mass. And now, how do you define the center of mass of a two-dimensional system? You define it based on the coordinates. So for example, the x coordinate is equal, just like before, it's going to equal to m naught, but in this case x naught over the total mass. And now the additional concept for this two dimension is that we have a y bar, and that y bar is going to be equal to, what do you think it is? It's going to be equal to this one, m y naught over the total mass. So this is how you define a two-dimensional system center of mass. So first you find the moment about the origin for each coordinate, and then you find the total mass, and then you do your divisions. Then you should be able to find the center of mass of a two-dimensional system. In the next video, I'm going to give you one example for this two-dimensional system. So don't forget to subscribe, please. Thank you very much. See you next time.